Alright, let's do some review for the exam. This is the November 2009 paper. I've extracted some questions that we've covered during the first year of this course. So we'll start with number 1, where we've been given a list of 8 temperatures in Geneva, and one of them is T. We need to find the value of T given what the mean is. So let's think about what the mean means. We've got 7 plus 4 plus 5. The sum of all of the numbers divided by the number of numbers is equal to the mean. So I have 8 numbers, and this will be equal to 7. So I can multiply both sides by 8 to move the 8 up, 56. And let's add all of these up. So I've got 46. I find that T is equal to 10. The mode is the number that occurs the most frequently, so you've got to imagine now that T is equal to 10. And in this list, the mode obviously is 4. 4 is the only one that occurs more than once. In fact, it occurs 3 times, so the mode is 4. And the median is the number in the middle, so we've got to place them in order first. We've got our 4, 4, 4, then we've got a 5, 7, 8, followed by the 10 and the 14. So we're going to move inwards until we reach the middle number. In this case, there's 2 middle numbers, so we're going to take their midpoint, their average, and we'll find that the median is equal to 6. Sorry, this gives us 12 over 2, which equals 6. So the median is 6, mode is 4, and T has been equal to 10. Number 2. We've got a Venn diagram that wants us to classify these 6 numbers into these different number sets. So let's quickly review what they all mean. R is everything, all of the real numbers. These are all of the possible numbers that you would ever have to know. And Q stands for quotient, which means division. That is to say, things that can be expressed as a fraction. We also know these as the rational numbers. The Z is the integers, and that's all of the positive and negative whole numbers. And then N is the natural numbers, and these are the numbers that you learn in before kindergarten. 0, 1, 2, 3, and so on. Another way of thinking about rational numbers is instead of just thinking about these as numbers that can be expressed as fractions, where in fact you've got a useful button on your calculator under math that looks something like this. If you press the math button on your calculator, you'll be able to convert between fractions and decimals. And if you convert a decimal to a fraction, that is to say, if you've been given a decimal and you can successfully convert it to a fraction, surely it belongs to the rational numbers set. If when you try to convert a decimal number to a fraction, it fails and just gives you that same decimal number again, maybe it's not rational. Another way of thinking about rational numbers is in terms of decimals. If the decimal number repeats, or if it terminates, that is to say it goes no further after that, then it is a rational number. The irrational ones, these are to say the ones that belong outside the rational circle, are the decimal numbers that might go on forever, and there's no discernible pattern. Alright, so let's classify these numbers. 1 over 4, I'm sure you all know this. We could also write this as 0.25. That's a decimal which does not go on forever. Therefore, it must be a rational number. Clearly not an integer. Now I can write it down as 0.25, or I can write down 1/4. It doesn't matter which, as long as you write down one of these equivalent forms. -3, this is a whole number that, well, that is to say it's got no decimal part, but because it's negative, it doesn't belong to the natural numbers, which are just 0 and higher. In fact, it's going to be in here. It's one of the negative numbers inside the integers. Pi, if you put this into your calculator, you'll see, in fact I can show this to you, second pi, and we've got 3.14159, 3.141592654, and it goes on. And if I try to convert this into a fraction, press math, and oops, looks like I got the function wrong. It's allows me to be able to put something into a fraction or a decimal. I want to convert this into a fraction. So what is my answer? Expressed as a fraction, gave me the same decimal number. Therefore, pi cannot be expressed as a rational number. It must belong out here. Cosine of 120 degrees. So I first got to check that my calculator is in degrees mode. Don't panic, this is not something you're going to have to do in the exam. We haven't done any trigonometry this year, so cosine and sine and degrees and stuff like this will not be on the exam. But anyway, this little preview of the future, let's put the calculator onto degrees mode. It always defaults to radians mode after you reset it, so let's change it to degrees, and now we'll quit and we'll type in what is the cosine of 120 degrees, and we'll find out that we get negative 0.5. Now that's a decimal that terminates, but I say a decimal, not an integer, because it's not a whole number, it's a decimal number that terminates, so I can write it down as a decimal, or I could write it down as the original expression of cosine 120 degrees. I'm just going to demonstrate to you that if we converted this one, or tried to convert it into a fraction, there we go, look, it works out nicely into negative 1/2. It is expressible as a fraction, it does belong to Q. 2.7 times 10 to the power of 3. I'm sure you don't need a calculator to do this, but if we did do 2.7 times 10 to the power of 3, we'd end up getting 2,700. Although it's a big number, that is nevertheless a whole number. Might not be a number you knew in kindergarten, but if you were able to count very high, so you can write it down in its standard form. 2.7 times 10 to the 3 would be its given form. And lastly, 3.4 times 10 to the negative 2. I can handle this by putting it into the calculator. 3.4 times 10 to the power of negative 2. And look, I end up getting a terminating decimal of 0.034, which we can write down as the original thing, a small number. The decimal has been moved over twice because of that scientific notation power. So we ended up with only one number in the naturals number set, and one number in the integer set, 3 numbers inside the rational set, and 1 number outside. Let's move on to number 3. A rectangle whose dimensions have been expressed in scientific notation, that, and we need to write down its area. So we know that area is equal to length times width, which in this case is 9.5 times 10 to the 2 times 1.6 times 10 to the 3. So let's put this into the calculator. 9.5 times 10 to the power of 2, and multiply it by the width, which is 1.6 times 10 to the power of 3. And that gives me 1,520,000. Now we need to express this in the form a times 10 to the k, where a is some number between 1 and 10. So let's move the decimal from the end of the number, because this is a big number, right? So the decimal's at the end. Let's move the decimal over. 1, 2, 3, 4, 5. I'm going to move it right there, because 1.52, that's a number between 1 and 10. If I had left it here, I'd have 15.2. It's too big. Or if I'd moved it all the way here, 0.152. It's too small. So this is going to be the number, 1.52. And how many times did I move the decimal place? 1, 2, 3, 4, 5. 10 to the power of, and it's a positive 6 because it's a very big number. If this had been a very small number, like 0.0000 blah blah blah, well then we'd end up moving the decimal place so that we still have a number between 1 and 10 in front of the decimal, but then we'd have a 10 to the power of negative some number. But this is a big number, so a positive exponent. Alright, Helen's estimate is 1,600,000. We need to find the percentage error. So our percentage error is going to be equal. Alright, formula package gives us as V sub E. So the exact amount, going to gosh, I always get this backwards, but thankfully the absolute value is going to save me. So I've got 1,520,000 minus, and she estimates it to be 1,600,000. And this difference, I'm going to take the absolute value of the difference to make sure it's positive. I need to divide it by the exact amount. So I'm comparing this difference between the exact measurement and her estimated measure, that difference divided by the actual measure, to see relatively how off that estimate is. Alright, so let's see. 1,520,000 minus 1,600,000. That looks good. And that amount, I'm going to multiply it by -1, which is just a clever way of using the absolute value to turn a negative number into a positive number. So I've got 80,000, and I need to divide that by 1,520,000. Okay. Right, so I end up getting 0.05263, and as long as I write down at least 3 significant figures, I'm fine. I'm going to write down 5. I'll convert this now into percentage by moving my decimal over twice. In the formula package, I think that they tell you to, at this point, to multiply by 100%. So we'll multiply by 100, end up getting 5.2632%. I'm just going to round to 3 significant figures. Alright, number 4, first term of an arithmetic sequence is 7, the sixth term is 22. We define the common difference. So the first term is 7, sixth term, and another way of writing the sixth term, which is always helpful in these kinds of questions, is u1 plus 5d, right? We're always adding 1 less the number of the common difference, and that's equal to 22. So u1 we know is 7. Okay, so looking at u6, by replacing u1 with 7, and realizing u6 is u1 plus 5d, we're able to come up with an expression for 5d. If I bring the 7 to the other side, it becomes a -7, which is 15. And then let's divide both sides by 5, and we end up discovering that d is equal to 3. Now let's find the 12th term. So the formula package tells you that un is equal to u1, oops, wrong formula. Alright, u1 plus n minus 1d. And so in our case we're looking for u12. Our u1 is 7. Our 12 is the n. So we're doing 12 minus 1, or 11 if you prefer. d, and d we just figured out in part A is equal to 3. So that equals 7 plus 11 times 3. 7 plus 33 equals 40. And the sum of the first 100 terms, so S100, there's 2 different formulas in the formula package. There's one which gives you something that looks like this. This one's useful when you have been given that last term. So if we're looking at S100, if we knew what the 100th term was, then that would be a useful formula. And there are some students who prefer to calculate what U100 is, equals 7 plus 99 times 3, and then they've got UN, and they just substitute in U1 and UN, and their n would be 100. There's another formula that I'm going to use here, which is n over 2, and then 2u1 plus n minus 1d, and this is the one that's useful if you already know what the common difference is. And since I know the common difference, I'm going to substitute into this formula. So my n is 100, so n over 2 is 100 over 2. 2 times my u1 of 7, 100 minus 1 times 3. Alright, let's work that one out on the calculator. I've got 100 divided by 2, oops, times, and in parentheses I can see I've got 14 plus 99 times 3, giving me a total of 15,550. And that's number 4. Number 5, we've got a cumulative frequency graph which shows the heights of students in a school. We need to begin by writing down the median height of the students. So we've got a total of 200 students, that's the frequency. The median will occur at exactly the halfway point of 100. And we can read this value as being 170 centimeters. Write down the 25th percentile. We know that 25% equals 1/4. That equals then the lower quartile. Right? That's what the lower quartile is. And so we'll take the midpoint between the median and the minimum. There's our lower quartile. And our 50 comes across and maps down to, looks like about 163. And then it asks for the 75th percentile. 75% equals 3/4. And so 3/4 of the way up my frequency. And I'm always going to be measuring my ratios like median and 25% and upper quartile, stuff like that. So this one's at 150. It's my upper quartile. I'll always be measuring that on the vertical axis. Okay? And that maps across, and then I map it down. It looks to happen at about 172 centimeters. Okay, and so those are my 3 heights in part A, B, and C. Then it tells me that the height of the tallest student is 195, that's right there, and the height of the shortest student is 136, that's right there. We need to draw a box and whisker plot. So let's just recall that our median occurred at 170. So let me draw a line for my median. And then I had an upper quartile at 172. That was my 75th percentile. And I had a lower quartile at 163. And I'll connect those lines to make a box. And then here are my whiskers out to my minimum and maximum.